My name is Karl-Heinz Sylla. I'm Senior Data Scientist at Fraunhofer Institute for Intelligent Analysis and Information Systems. The Lambda architecture is a scalable, fault-tolerant data processing architecture coined by Nathan Martz and based on his experience in developing and running big data applications. The Lambda architecture is a useful conception to design applications. It helps to identify the requirements on scalability and to select appropriate components. Incoming data records are considered as events to be logged. Each data record holds or is completed by a timestamp defining when the information is considered truth. Data records are added to the master dataset. Stored data records are handled read-only. Immutability of data is a crucial concept. It makes the data system robust against data corruption or data loss. Data errors are compensated by adding new correct data records. Immutable data is easy to handle in computations. It may be replicated freely, for example, to increase fault tolerance or to handle bulk requests in time. The architecture names 3 layers of big data processing: the batch layer, the speed layer, and the serving layer. The batch layer holds the master data set. It comprises processing facilities that compute derived information for analytical processing at the serving layer. A batch run produces a batch view, which is an immutable, self-contained version of derived data. Information becomes available in the batch view with a latency caused by the processing time of batch runs. The speed layer produces incoming data at high velocity and stores result into the real-time view. The speed layer bridges the latency gap of batch views. Data in a real-time view is mutable because new information must be available as soon as possible. Information, meanwhile available at the batch view, may be removed from the real-time view. The serving layer responds to analytical queries. It accesses and merges the information of the batch and the real-time view. This diagram shows the aspects to scale out the big data components of the Lambda architecture. The master dataset scales out to handle big volumes. The batch function scales out in order to enhance the parallelization. The batch view has to scale out because of the volume and because of bulk user requests. Incoming data at the new data component scales out for volume and, of course, for velocity. Like the speed function also scales out for velocity, and the real-time view mainly has to handle bulk user requests and may be scaled out under this aspect. An application may not need the fully fledged architecture and may also integrate non-big data components. For example, a monitoring application may run complex event processing at high speed to provide information in real time. Results are stored in a non-big data in-memory database, which provides fast analytical processing of the derived data and serves real-time dashboards in a small number of workplaces. Data analysis of historic data and thus maintaining a master dataset may not be necessary. A reporting application produces information to be updated at daily rate. This application is constructed only at the batch layer. Analytical batch runs are sufficient to produce the reports in time. Backed by the concepts of the Lambda architecture, you understand the context of big data components. You may assess portfolios of big data distributions and you are encouraged to discuss and design big data applications.